the idea is here to very briefly present a small part of research that we have done on MEDPOWER project. This is a project that we are trying to build a small multi-purpose vehicle, which will be the bus or something else, delivery vehicle. But let's focus on the design of battery pack, because this vehicle should be around 5 tons, 5,000 kilograms, top speed 100 kilometers per hour, and range around 300 kilometers. So when we try to get a grip of this battery pack, we decided to go to around 600 volts of voltage and have a module of 50 kilowatt hours. So this vehicle could have 1, 2, or 3 modules expand depending on the purpose of each vehicle. So this module of 50 kilowatt hours will be divided into 7 bricks, and each brick will have 12 blocks. This is the story of the design of the block. So this block has 32 battery cells connected in 2S16P configuration. So in total, the module has 168 cells and weighs roughly around 190 kilograms. The data, I won't go through those through that data because you have it all in the paper. I will go quickly on. When trying to get a grip on this battery pack or the block, we thought only for the beginning of temperature. So try to avoid overheating. First, in this research, we have done some modeling of movement of vehicle on specific route. We choose a very hard route and move a vehicle along, of course, virtually. And the top power that the vehicle needed was around 100 kilowatts. So basically, depending on that part, we said, okay, this peak power of 100 kilowatts needs a maximum current of a module from the module of 160 amps. If we have a battery cell with 5,000 or 5 amp hours, 1C means 5 amps. 5 amps with 16 cells in parallel gives us 80 amps. We need 160 in total for peak power. When we have 100 kilowatt hours, 2 modules, then this is exactly 1C. At 1C, we don't expect that battery cell will heat, okay, or overheat, because this is 1C. Usually today, we have tested our battery cells and they did not heat. You will see that later. They did not overheat. So we took that problem off the table. The following problem when managing battery cells and their connections, if we use nickel-plated strips, then sometimes if you have a very a smaller cross-section, then you have heating of nickel-plated strips, and then that is the source of heating for the cells, which is not good. So we took more, used more time to research on tabs and come up with a tab from copper, and did some research on it. So actually, though this is all modeling, so this is all model, did in 3D, and after that we put it in console and try to find out the temperatures, highest temperatures in that tab. This is actually what we have done, and I told to my colleagues, young colleagues, assistants, that this is almost like 3D modeling. They should take pictures in more real world. So they used the same scenery as in modeling. So you don't see the difference, but okay, I will return. But if you compare the previous slide with this one, there are very small difference, but this is real. This is real model that we produced, and those are real tabs. Below tab, which connects all battery cells, and upper tab, which is one for the plus and one for the minus pole. And this battery block is, as its name says, a building block which should be easily produced and easily connected one to each other. 6 blocks will give us one brick. So we try to, from console, we put all the necessary data in console and try to have some sort of simulation to see what is the gain, temperature gain, if we have 1C or 80 amps, which is should be normal for our battery cells. And if you can see, from 27 degrees, it was very hot that day when we did all those. So in that room it was 27 degrees. We started from 27 and ended to almost 31 degrees. So only 4 degrees in hotspot gain of temperature. For 160 amps, we have a gain of what, 6.5 degrees, and for 200 amps, a little bit more, 8.5 degrees. But nevertheless, top temperatures were very okay. So this is the equipment that we used for testing, and actually you can see here we connected everything on this tab, or all connection points for battery cells we connected, and took two here and here, took two probes, temperature probes, to see what really would have we will come up with in the experiment. So this is comparison between measurement, experiment, and simulation. You can see in a measurement from 29 to 32, and I will just run down faster because we don't have enough time. From 30 to 36, and for 200 amps from roughly 32 to 40. So all of those temperatures are well below any problematic temperature. Of course, if we remember that we need only approximately 80 to 100 amps, this is a very, very cool environment for this type of equipment. So we can easily say that we will not have any temperature problems with battery blocks, and we will see when we put all of them into one casing, do we even need something to cool them, or something, or just I don't know, assure some kind of airflow to just run down warmer air out of this casing. So further on, of course, we have to put blocks into a brick, put into casing, and did some measurement of temperature. But nevertheless, we do not expect that we will have a lot of problems with this. So, thank you very much. I was trying to be quick. Questions, please.
Varios Serialis from Polytechnic Milan. Which technology of the battery cells did you use?
21700.
The technology of
what, connecting?
Of the cathode?
To connect copper to what technology of what?
Of the battery cell.
Battery cell is lithium-ion. 21700.
Okay, and which was the
Samsung.
Okay, and which was the highest temperature number that you said, the threshold? That you said after 45 degrees you can find problematic.
No, it's much higher temperature. For thermal rundown, runaway, it's much higher. I would say I will not go above 65 or 70 degrees of Celsius, but below that, I don't expect any problems. Because you never know what could you expect, because that series of manufactured cells, they say, okay, you can go up to 100, 110 for thermal runaway. Okay, you don't have a problem. But if you need only one cell to make a problem for the whole battery pack.
Thank you.
Anton Hinek, I have one question. Did I see correctly that there's some error between like your measurement, the temperature, and then the simulation that you did?
Yes, because we first did the simulation, then we did the measurement, and actually we compared the delta.
Okay, I see.
Not so from the start to.
And where does the error come from? Do you know? Like, is there like some setting in console, for example, that doesn't really represent your actual implementation? Or
Well, error was, I think, of what you call DC offset. The starting temperatures was not the same.
I see. Okay.
This is the problem, but the delta that you gain was almost there.
Thanks.
Well, thank you very much.